from Polytechnic University of the Philippines, San Pedro campus, Bachelor of Science in Accountancy, third year section 1. And I'm here to discuss the two main types of statistical tests, the ANOVA and MANOVA. And this is for our final requirement in quantitative techniques for decision making with our beloved Professor Robert De Castro. And first, we have the definition of ANOVA. ANOVA is analysis of variance. It's a test of three or more groups for mean differences based on a continuous or a scale or interval, response variable, or independent variable. Another definition of ANOVA, it is a statistical technique that assesses potential differences in a scale level dependent variable by a nominal level variable having two or more categories. For example, an ANOVA can examine potential differences in IQ scores by country, United States versus Canada versus Italy versus Spain. Now, I will discuss the two main types of ANOVA. First type, we have the one-way ANOVA. It compares levels or groups of a single factor based on single continuous response variable or comparing test score by level of education. Here in our illustration, it simply describes our definition of one-way ANOVA. We have the one variable, the level of the education, describes of one dependent variable of test scores. We have the college degree, graduate degree, and high school degree. It simply describes that the highest test score we have the graduate degree, and the second one we have the college degree, and the least score we have the high school degree. Next type of ANOVA, we have the two-way ANOVA. Two-way ANOVA, it compares levels of two or more factors for mean differences on a single continuous response variable. An example of two-way ANOVA is comparing test score by both level of education and zodiac sign. Here we have in our example, you have the illustration or a graph of a two-way ANOVA. We have this test score simply describes the two dependent variable. We have the zodiac sign and the level of education. We have in a high school, we have the 77 Libra of zodiac sign with a 53 of level education in high school. Well, in the highest, we have in the graduate degree, we have 93 test score on a zodiac, while in the level of education, we have the 99 score of it. Next. MANOVA. MANOVA is the second main topic of our discussion for today. MANOVA is a multivariate analysis of variance and is an ANOVA with two or more continuous response variables. The purpose of MANOVA is to prevent type of error. What is a type 1 error? Type 1 error, it occurs when ANOVA have three or more dependent variables. Next, we will discuss the two main types of MANOVA. First type, we have the one-way MANOVA. One-way MANOVA, when comparing two or more continuous response variables by a single factor, a one-way MANOVA is appropriate. In example, comparing test score and annual income together by level of education. In our illustration, we simply describe the definition of the one-way MANOVA. Here we have the independent variable, we have the factor of level of education, three level of education, high school, college degree, or graduate degree, simply describes the two dependent variables, we have the test score and the annual income. Next type of MANOVA is the two-way MANOVA. A two-way MANOVA also entails two or more continuous response variables, but compares them by at least two factors. An example of comparing test score and annual income together by both level of education and zodiac sign. Here in our illustration, in two-way MANOVA, we have the two independent variable, one, the level of education, two, the zodiac sign. First factor is the level of education describing the two dependent variables, which is the test score and the annual income. In the same way, in the zodiac sign, we have that independent variable simply describes the two dependent variables, the test score and the annual income. Now we will show some examples in illustrations in how ANOVA and MANOVA works, how the two statistical types will use in SPSS. We're here to discuss the ANOVA and MANOVA tests. After we discuss definition, we will use and show you how to use these two tests in SPSS. We will use existing data from the Lyceum of the Philippines. This SPSS conducted from the Lyceum of the Philippines, from the respondents or the students from it. This is existing data. First, we have the research question that will find out if there is a significant difference between the length of service and the benefits that employees could have. Then we have the null hypothesis that there is no significant difference between the length of service and the benefits that employees could have. Now we will use the one-way ANOVA test. How we will use it? First, type the analyze, compare means. It shows different kind of tests, but we will use the one-way ANOVA test. Click the one-way ANOVA. It shows the different type of variables. Then we will use this kind of variables, the length of service, as the independent variable, as a factor. And we'll find the benefits, drag down, click the benefits as a dependent factor. Now click the options and fill up all the boxes: the descriptive, fixed and random effects, homogeneity of variant tests, Brown Forsythy, Wicks and means plot, and continue. Post hoc, the Tukey, and continue. Now we will show the interpret of the one-way ANOVA test. This is the descriptive statistics data from our test. We have the below 1 year to 5 years, 5 to 10 years, and more than 10 years. Then we'll interpret it while saying this statement that employees with a length of service more than 10 years have the highest benefits with a mean of 3.7500, while the other one, the employees working to 1 to 5 years, have the lowest benefits with a mean of 3.2425. Now we'll see the test of homogeneity of variances. The level of significance is more than 0.05, which is in the test we have the significance of 0.202. Therefore, we are not violating the homogeneity test of variances. If the level of significance is less than 0.05, we have to check the robust test of equality of means. Now, we will show the ANOVA. This data in ANOVA test. There is a significant difference between the two variables since the level of significance is 0.001, which is less than 0.05. Now next, the post hoc test. This is the summary of all the data and table given above. It shows the different variables. We have the below 5 years, 1 to 5, 5 to 10, and more than 10 years, and dependent variable with the benefits, with the mean, standard error, and the significance. Now, we will show you, let's see the means plot, since there is a significant difference. This means plot, we have the two variables, the mean of benefits and the length of services. We have below 1 year have the lowest mean and goes the 1 to 5 years, 5 to 10 years, and we have this more than 10 years having the highest mean for the length of service in the given data. And that's it for the one-way ANOVA test. After we discuss the one-way ANOVA test, now we will show you how to use the MANOVA test in SPSS. Now, we will use also the data from the one-way ANOVA test, which is the data from the Lyceum of the Philippines. Select the data to show this kind of different variables from the data from the Lyceum of the Philippines. In this multivariate test, na MANOVA, we get the same data. So, in this test, we have different, or it is not similar, research question from the other test we have from the ANOVA test. In the MANOVA test, our research question is if there is a significant difference between length of service and the safety, health, and benefits of the employees. We have this null hypothesis that there is a significant difference between length of the service and the safety, health, and benefits of the employees. So how we'll use this MANOVA test in the SPSS? First, we have to click also the analyze. Next, we have the general linear model and select the multivariate or the MANOVA test. It shows different kind of variables, but we will use as the independent variable the length of service. It's a fixed factor, and in the dependent variables we have three. the safety, health, and benefits. Yeah, select the safety, enter this as dependent, health as dependent also, and lastly, benefits. Benefits dependent variables. We have options. Click the length of service to display means for overall. Next, to display, we will fill up these boxes of the descriptive statistics, estimate of effect size, observed power, homogeneity test. Continue. We also click the post hoc, length of service post hoc test for the length of service, and equal variance assumed by the Tukey, and continue. And okay, this is the MANOVA test. This is the result of data from our test, the multivariate. This descriptive statistics, this is the result of data from the respondents. We have the independent variable, the length of service, from below 1 year, 1 to 5, 5 to 10, more than 10, as described as the three variable as the safety, health, and the benefit. First, in the safety, we will get the highest mean, no more than 10 years in terms of the safety, means of 3.6875. And in terms of safety, we have the lowest mean of 3.3350 in the 1 year to 5 years. In the variable of health, we will show the highest mean from the more than 10 years, we have 3.4125, and the lowest mean from below 1 year, 3.25600. In the variable benefits, the highest mean we have more than 10 years, we have the mean of 3.7500, and the lowest mean we have 1 year to 5 years of 3.2425. So as we analyze, as we see in the data, that majority more than 10 years have the highest mean, and the lowest mean below 1 year as having a low time of experience from their job. Now we will see the box test of equality of covariance matrices. Think of it as the homogeneity test of variances. It is not violated since the level of significance is more than 0.05. In this test, the significance is the 0.360, so it's not violated since the level of significance is a 0.05, as I repeat from the other test. Next we have, this is the multivariate test. Regardless of which of these multivariate statistics, we will look at in this test. We have the length of services and other variables and the test on it. Now we will look at that they are all significant. So in this Levin's test of equality of error variances, there is no significant differences from the safety, health, and benefits. Now scroll down. We will show you the post hoc test as a term of the length of services. This is the overall data from the table or the test given above. So we will just see if the significance of this test is greater than 0.05 or less than 0.05. We'll show we have the mean difference, standard error, significance. Also, I said earlier that the 0.05 greater than or lower than, and that's it from the MANOVA test. Simply as that, and thank you for listening.